So we will now proceed with group 4A elements. So yung group 4A elements naman, this is known as the carbon family. Okay, carbon family. So ibig sabihin, yung flag bearer, yung first on the list, yung leader ng group 4A elements is si carbon. Okay, so giname siya based on the first element on the list of atoms or elements in the group. So members under this group, we have the carbon, silicon, tin, lead, and germanium. Okay, so we'll have the general properties first, bago yung individual elements. For the general properties ng group 4A elements, yung elements of this group have a positive 4 oxidation state. Okay? Which means, pag sinabing plus 4, positive 4, it means they share 4 valence electrons. Okay? They are able to share 4 valence electrons during chemical reaction. Ma'am, bakit share? Bakit hindi lose? Bakit hindi gain electrons? It is because yung elements under, most of the elements under group 4A na family, especially yung carbon, silicon, they are able to form covalent bonds. And remember, when we say covalent bonds, there is no gaining, there is no losing of electrons. Basta mag-form of covalent bonds. Ang kakahitabo sa covalent bonds, there is sharing. Diba? There is sharing of electrons. Okay? So, yung carbon, yung silicon, especially, they exhibit covalent bonding with itself. Ibig sabihin, they can form covalent bonding with itself. Carbon to carbon, pwede yan. Meron ding silicon to silicon. That is a covalent bonding between itself. Diba? So, capable ang carbon and silicon with covalent bonding. Again, covalent bonding, that forms between non-metal and another non-metal. Comparing to ionic bonding, sa ionic bonding, it is metal and a non-metal. That is why there is transfer of electrons, there is gaining and losing of electrons, basta ionic bonding. But with covalent bonding, there is only sharing of electrons because, again, the bonding is in between a non-metal to a non-metal. Okay, ibig sabihin, carbon, di ba carbon is a non-metal, silicon is also a non-metal, but not all elements under group 4A, non-metals. Kasi yung tin, it is a metalloid, pero higher yung non-metallic property niya. Yung lead, isang metal ang lead. Diba? So, variety yung properties nila when it comes to metal and non-metal properties. Okay? Now, for the oxides of these elements, it is said to be acidic in nature. Okay? Acidic in nature. Kasi nga, carbon and silicon are said to be non-metals. And I have introduced to you nga kapag oxides of non-metal, example, carbon as a non-metal, it forms an oxide, example, carbon dioxide. So, isang non-metal oxide that is said to be acidic. Kasi nga, if it is dissolved in a water solution, it forms acidic compounds. Okay, so the same with silicon. as a non-metal kung naa kay oxide of silicon, example, silicon dioxide. That is also considered acidic. So tandaan, oxides of non-metal in general, acidic. Oxides naman of metal are said to be basic. Okay? So we'll begin the discussion, the individual discussion of the elements, starting with carbon. Okay? So kahit hanggang carbon lang for this morning, and then we will have the rationale of the long quiz that we had last week. Okay? So carbon. Carbon, this is considered as the king of all elements. Okay? Siya yung pinaka-king of all the elements. But when it comes to metals, ang king of all metals is kinsa gani ang king of all metals?
Gold, ma'am?
Okay, gold. But among the elements sa periodic table, it is carbon. Bakit siya yung king of all elements sa periodic table? It is because it is able to form million of compounds. There are more compounds that it can form than any other elements. Okay? Pero syempre, di natin aaralin yung lahat ng compounds na may carbon kasi may separate segment, di ba? May chemistry that talks about carbon-containing compounds, and that is organic chemistry. So kung mahuman mo sa PChem 1, you can proceed next semester sa organic chemistry. So doon natin aaralin yung mga carbon-containing compounds. So one of the reason again bakit carbon is the king of all elements, it forms a lot of compounds, million of compounds comparing to other elements. Aside from that, it is also able to form stable nga mga compounds to, or it able to bind with other elements forming a stable compound. Example, pwede siyang mag-bind with oxygen, forming stable carbon dioxide. It can form bonding with hydrogen, forming hydrocarbon compounds na stable, and many other atoms pwede niyang i-bind, forming stable compound. Okay? Also, king of all elements siya kasi it is considered the essential element of living matter or the organisms. Bale, halos nagko-compose sa living living matter, example sa humans, sa animals, any living species, ang nagko-compose sa kanila is mga organic na compounds. Okay? So, very essential element yung carbon. Kasi, once ang compound is said to be organic, meaning meron siyang carbon on it. Okay? So, essential element ng living matter, yung carbon. Okay? Non-metallic siya. Take note, non-metallic siya in property. And as mentioned, maximum valence niya is 4. Okay? For its occurrence in nature, for its occurrence or existence in nature, it usually occurs in nature as carbonate ores. Okay? So, ito yung mga minerals, how carbon exists as carbonates, as carbonate ore. Example, calcium carbonate, magnesium carbonate. So, lahat ng yan, it contains carbon in a form of carbonates. Okay? So, yan yung occurrence, natural occurrence ng carbon in nature. Okay? Also, another occurrence or existence ng carbon is in a form of gases. Example, yung marsh gas, that is the methane, yung methane gas, CH4. Okay? Yung methane gas, CH4 or yung biogas. I think familiar man siguro mo, methane gas, biogas, that is marsh gas. Okay, so meron siyang carbon. Carbon dioxide gas, that is also one of the occurrence of carbon. So in a form of gas. Okay. Another thing, yung carbon, it is able to combine with oxygen to form a stable carbon dioxide gas. And in a room temperature, kani karon, kung asa mo karon, at room temperature, relatively inert ang carbon dioxide gas. Okay? Meaning, it do not, pag sinabing inert, kung maka-encounter mo term nga inert, meaning it do not undergo chemical reaction under a set of a given condition. Okay? So, hindi siya nagre-react. Okay? So, kalmado lang siya at room temperature. Okay? So, dili siya ga-cause of any nga mga chemical reaction at room temperature. Now, another property of carbon, this is actually based on organic chemistry, which is a very important property of carbon, catenation. Tandaan nyo, one of the important property ng carbon is catenation. Catenation carbon. Ano yung ibig sabihin ng catenation? Ability yan ng carbon to form multiple bonds with itself. Again, kaya niyang mag-form ng multiple bonds within itself. Kahit yung surrounding niya is carbon, kaya niyang mag-form ng multiple bonds within itself. Pwede in a straight chain, in a branched chain, or in a closed chain. Or pwede double bond with carbon, triple bond with carbon to carbon. Okay, so yan yung catenation. Kaya niyang mag-form ng multiple bond within itself. Okay, so this will be more discussed in detail sa organic chemistry. How does straight chain form, branch chain, closed chain are formed, and how it is being named. Okay, so that is the property. For now, just know na that is one of the important property of carbon, catenation. Okay. Now, with its production ng carbon, carbon as an element, it can be produced, it can be present in various forms. Example, pwede siya present in metallurgic na coke. Okay. Dili ni siya coke nga katong beverage siya. Katong metallurgic nga coke, which is used for steel production. So, mag-search mo about steel production. Kailangan kasi yan ng metal coke. Okay? So, yung carbon as an element, pwede siya present in this form as metal coke. Again, this is used for steel production. Isa siyang impure form of carbon. So, yun yung mga impurities. Dili gud siya pure carbon lang. Meron siya mga impurities. And paano siya napoproduce? Coal lang. You have a coal and heat that extremely under elevated temperature but with the absence of air. Okay, so free from air. So that is how coke, metallurgic coke is produced. Another form of carbon is charcoal. Okay, so ito yung mas kilala nyo, yung charcoal. Ayan yung ako sa erase ha. Yung charcoal, uling. Sa Bisaya pa uling. Mauna na siya. Mauna si charcoal. Okay? So, pwede ka na ang form ng carbon. Diba carbon naman yan? Yung charcoal. Okay? So, that is usually produced when heating slowly or burning. I-burning mo slowly ang woods. Diba? So, you can produce, out of that, you can produce a charcoal. Okay? So, yan yung coal. Ito yung coke. Okay, impure form ng carbon. Ang lamp black, yung kanina, ito. Ito yung, ayan. Yan yung lamp black. Okay, it is a black pigment that is very small in particles. Okay, so very porous, very fine powder of carbon, which is usually obtained from soot. Okay, kanang carbon soot. Usually kanang ano, kanang magluto bitaw ka nang sa ilalom sa kaldero. Kung kahoy inyong gamiton magluto, kanang ilalom sa kaldero na mga itom-itom kung dili gid siya malimpyuhan hantod pila na ka man sige gluto mubaga man na iyahang murag carbon sa ilalom sa um, kaldero. Kung imo na siya scrape, that is actually lamp black. Okay? So, yan yung mga possible forms or, various forms ng carbon. Okay? So, yung characteristic color is black. Okay? Ayan. Then, ito naman, ano lang to mga manifestation. Ganun din, general forms ng carbon. Merong crystalline, merong amorphous. Okay, crystalline form, example yung graphite, diamond. Okay, these are actually allotropes of carbon. Okay, kung may kag allotropes of carbon, yan ay property ng carbon to exist in two different forms or two or more different forms in the same physical state. Okay, so ito yung mga allotropes ng carbon. Again, when you say allotropes, property of a carbon to exist in two or more different forms in the same physical state. So yung graphite, diamond, ito yung allotropes, crystalline allotropes ng carbon. Graphite is the most stable one. Ito yung used in pencils, lead. Okay, yung tip ng pencils, that is actually made up of graphite. Okay? So, yan yung graphite. And then, for diamond, unstable naman siya na allotrope. Okay? Ng carbon. But take note, they are both crystalline forms of carbon. Then, for the amorphous, pag sinabing amorphous, kanang finer nga texture of carbon. So, pwedeng in a form of coal. So, ito yung coal. And yung nasa baba is yung anthracite. Okay, so we actually have two forms of coal, the soft coal and the hard coal. Okay, so just take note of the differences sa components ng carbon. Okay. So, that is for the properties ng carbon. Okay. So, we will now have the compounds. Just a few compounds of carbon. Yung mga na-mention na natin, example, si activated charcoal. Di ba? Na-mention ko naman siya sa mga previous group of elements. Yung activated charcoal, di ba? Part siya ng universal antidote. Okay, so in particular, yung activated charcoal, ayan, that is actually a residue. Residue siya from a process called destructive distillation, okay, of an organic material. So, this is actually a setup. Ito yung setup, paano gawin yung destructive distillation. Okay, so say for instance, you have an organic material, usually wood, pieces of wood, any kind of wood. Imo din siyang ilagay sa vessel for destructive distillation. I-heat na nimo. Then later on, in this part, na ay ma-produce ng mga particles, black particles. Okay? So yung mga black particles na yun yung coal. Okay? Or mga coal tar. Okay? Usually, ang term man sa coal is a tar. Or pwede na sila isumpay. Coal tar. Okay, mga itom-itom ng mga particles. Yan yung magiging source ng activated charcoal. Okay, so galing siya sa coal tar. Kaya nga coal, mga chars ng coal. Okay, mga coal tars. Okay, so yan again yung source, origin, yung pinanggagalingan ng charcoal for it to be activated. Now, paano siya naging activated charcoal? Para ma-activate siya, ibig sabihin ng activated kasi na term for a charcoal, ibig sabihin na enhance yung adsorptive property ng charcoal. So once activated na yung charcoal, meron na siyang ability or adsorptive power. Okay? So paano yung activation or activation ng charcoal? Via treating, i-treat lang. So you have a charcoal, plain charcoal, na din ay process kung saan it is being treated with the following. Okay, this treated with oxygen, zinc chloride, carbon dioxide, sulfuric acid, phosphoric acid. Okay, so nga na usually ang process, na siya particular specified process to activate charcoal to make its absorptive power enhanced. Okay? So, kung destructive distillation lang, plain charcoal lang ang imuhang makuhaan. Okay? So, kailangan pa siyang i-treat for it to be activated, for it to be called or have an adsorptive power. Okay? Or ability. So, yan yung production ng activated charcoal. Now, we have two forms of activated charcoal. Merong fine, okay, so powder-like nga charcoal, activated charcoal. So, ayan. Yan yung finely powdered nga activated charcoal. So, it is used as adsorbent mixed with liquid medium to treat diarrhea. So, ito yung ginagamit for antidote purposes. Okay? Kanang antidote purposes, detoxifying purposes na charcoal. Syempre, yung finely divided one. Okay? Finely powdered na form ng activated charcoal. Okay? Again, ito yung component ng universal antidote, yung finely powdered na activated charcoal. Para saan ba yung universal antidote? Universal, pwede siya used sa majority of poisoning conditions. Pero, hindi lahat ng poisonings kayang i-treat with the use of universal antidote. Remember, ang activated charcoal as an antidote, isa lang siyang adsorbent. Ibig sabihin, didikit lang siya sa toxins. Okay? Didikit lang siya. Hindi siya magpe-penetrate sa any part of our tissues. It will just adhere. Okay? Didikit lang siya sa toxin, sa surface ng toxins. Now, paano naman kung ang poison na-absorb sa body? Say for example, yung cyanide poisoning. Pag cyanide poisoning kasi, this is a cellular type of poisoning. Okay? So meaning, absorb yun siya sa katawan na poisoning. Therefore, hindi kaya ng adsorptive power lang ng activated charcoal. So, these are examples of poison na hindi kayang i-treat ng activated charcoal. So, yung kailangan ng cyanide poisoning is syempre yung mga agent na may yung may absorptive, okay, power. Okay? So, cyanide poisoning. Usually, ang ginagamit for cyanide poisoning is yung amyl nitrite. Okay? Amyl nitrite na agent. Okay? This is used to treat cyanide poisoning. Okay? Kerosene poisoning, that is also, another condition that cannot be treated with activated charcoal. Ganun din kasi yung kerosene, na-absorb din siya sa body. Okay, sa tissues. Um, Possible ni siya nga poisoning no sa mga children. Syempre kung nanakay pangutok, kinsabay mag-inom og kerosene sa ano rin sa mga children. So careful gyud kung magbutang-butang og mga poisonous agents nga reachable ng mga kids, children. Delikado gyud na. Kay nay uban, kasagara gyud nga kerosene poisoning among children pataka inom kay curious biya ang mga bata. So antidote ani is mineral oil, cooking oil. Kasi yung kerosene, the same iyahang polarity with mineral oil, cooking oil. They are non-polar. Okay? Dumduman lang ninyo ang principle ng dissolution. Like dissolves like. So, para matanggal ang kerosene being absorbed in the body, kailangan din ng the same property ng kerosene. Okay? So, non-polar to non-polar. So, non-polar kasi yung mineral oil, non-polar yung cooking oil. Okay? So, those are the antidotes usually ng kerosene poisoning. So, these are again examples of poison na treated with activated charcoal. Again activated charcoal cannot treat this because aside from adsorptive lang yung power ng activated charcoal, nagkukos din kasi ng vomiting at saka vomiting or kanang dizziness yung activated charcoal. Kung nagkukos siya ng vomiting, delikado siya sa mood kung may kerosene poisoning. Kaya kung kerosene poisoning mang yun, ang kakahitabo, ang kerosene, it may burn the food pipe, meaning it may burn the esophagus. Okay, so ang esophagus, pwede ma-burn with kerosene. Now, kung mag-induce ka og activated charcoal, pugson yun nimo nga, activated charcoal lagi makapawalaan na, makatreat ng kerosene poisoning. Si activated charcoal, it can induce vomiting. Aman mo agi ang vomit, diba sa esophagus. So, mas masamot, matrigger na noon ang iyahang symptoms. Diba? Na-burn na gani imo ang esophagus, imo pag yung contract ang esophagus upon vomiting caused by activated charcoal. Sumusamot ang condition. Okay? So, that is also one of the reason bakit hindi pwede yung activated charcoal for kerosene poisoning. Okay? So, that's for the important information for activated, charcoal. Ayan. Then for the remaining na mga compounds, we will just discuss the oxides and the carbides. Okay, so yung mga simple compounds lang ng carbon. So carbon dioxide naman, this is also known as carbonic acid gas. After damp or air, air na siya, A-E-R. Okay, air fixus. Okay, so isang colorless, odorless gas. Sa hospital or sa industrial setting, again sa hospital industrial setting, kani nga gas, syempre nana sila mga any gas, any kind of gas, nana sila container. Okay, specific cylinder kung asa gina-contain ang mga gases. Well, in the case of carbon dioxide in the industrial setting, it is commonly contained in a gray-colored cylinder. Okay, kung ano na siya, protocol na gina siya always, nga basta container gani ng carbon dioxide, color gray. Naka-color coding gina always ang mga cylinders ng gases. Another example, si oxygen sa hospital setting, unsay color sa tangke sa oxygen gas sa hospital. Minsan may kuan na dere, na-admit na. Unsay color usually sa tangke, sa cylinder, sa oxygen gas? Any idea?
Green, ma'am?
Yes,
Gray, ma'am.
color. Yeah, color green. Correct. Okay. So, for that example, mo po na ang um, uniform nga color for oxygen gas. Yan yung kulay talaga ng cylinder container ng oxygen gas. So for carbon dioxide again, take note, kulay gray. Kulay gray yung container ng carbon dioxide gases. Okay? Now, sa pharmaceutical preparations, the gas na carbon dioxide, it enhances palatability, it enhances the taste of preparations, for instance, preparations ng effervescent solutions or effervescent na mga preparations. Okay? Example, say, familiar ba mo sa fluimucil? Kanang acetylcysteine. Para ni siya sa ubo. Fluimucil nga brand. Okay, para sa ubo, yung Berocca. Okay, Berocca. These are examples of effervescent nga mga granules. Effervescent. Fluimucil, natay granules ng fluimucil, napay granules ng Berocca. So it is being dissolved in water prior to administration. So kana sila nga mga preparation, naana sila compound that will enable to release the carbon dioxide once dissolved in water. So once ma-release yung carbon dioxide in the water, na-enhance yung taste ng preparation. Kung wala gani compound that carries carbon dioxide in this preparation, pait. Pait ni sila. Pait si Berocca, pait yung fluimucil, ilahang taste. So para ma-enhance lang palatability, they are usually added with a compound that will enable to release carbon dioxide once dissolved in water. Another example is a beverage. Diba? Yung sa Coke, any soda drinks, they are added with carbon dioxide. Bantog lami ang soda drinks. Kung imo ra naman pasagdan ang soda drinks na open, naka-store, naka-standby at room temperature, naka-open, ma-evaporate ang iyahang carbon dioxide. Siyempre, gas man si carbon dioxide, ma-evaporate din na siya, ma-escape din na siya sa iyahang container. That's why, dili na din siya lami. Okay? Pero with high pressure, kung i-ref siya, naka-close ang container ng soda drinks, naka-compress ang carbon dioxide, so collected pa, accumulated pa yung carbon dioxide. So, lami pa ang taste ng soda drinks. So, enhanced pa iyang palatability. So, that is one of the use ng carbon dioxide, enhancing palatability ng effervescent preparations or beverages. Okay. Another use of carbon dioxide is it is considered the most powerful nga stimulant for breathing. Okay, again, most powerful stimulant. It stimulates breathing. Okay, so respiration. In fact, pwede siya for the treatment of persistent hiccups. Ang hiccups, sa Bisaya ka ng sidok. Kanang sidokon, bitaw ka. Sidok. Familiar mo siguro mo ng sidok. Hiccups, yan yung involuntary contraction. Nagkakaroon ng involuntary contraction sa imong diaphragm. This is commonly caused by sudden or brief nga closure of vocal cords. Okay? Producing then a characteristic hiccups na sound. Okay, so a treatment that could stimulate the breathing is carbon dioxide. Okay? Then for its toxicity, pwede ka ma-poison with carbon dioxide. Mainly, kani nga cases, this is due to suffocation, kung ma-suffocate sa carbon dioxide nga gas. Kanang wala nag oxygen, ang imo nang gaka-inhale kay carbon dioxide. So carbon dioxide suffocation, that could be the cause ng toxicity of carbon dioxide. So ano yung antidote or aid para ma-counteract yung toxicity due to suffocation? Kailangan lang ng carbon dioxide absorbers. Example, yung mga na-discuss na soda lime, mga barium hydroxide, yung sa astronauts na ginagamit, yung lithium hydroxide. Okay, these are examples of carbon dioxide absorber. Ina-absorb nila yung carbon dioxide producing water and other byproducts. So, yung water will then be the source of oxygen then. Okay. Next, we have solid carbon dioxide. Solid carbon dioxide, this is also known as dry ice. Okay? So, yung uses niya, pinaka-common nga use ng dry ice is as refrigerant. Okay? So, refrigerant siya, ginagamit as cooling agent. Okay? Cooling agent. Okay? So, cooling agent siya, usually to preserve food, kung may mga frozen food or mga medical products nga kailangan i-ship mula from this area to a malayo nga area, syempre kailangan frozen man gyud daw ang food, medical, na may mga medical products na kailangan gyud siya frozen. Example, mga suppositories. Okay, dapat naka-maintain gyud ilahang low temp. Okay, frozen man. So, low temp dapat. Okay? So, usually, ang ginagamit as refrigerant is solid carbon dioxide. Or, pwede din siyang gamitin to cool materials during production. So, yan yung ibig sabihin ng refrigerant. Basta cooling agent siya. Okay? And then, there are also solid carbon dioxide that are used as lasers. Okay? Source siya ng laser para mag-treat ng skin conditions like acne, warts, so mga skin condition, callosis, moles, alum, eczema. Okay? So, example sa illustration, laser lang, pwede matreat, matangtang ang warts. Warts man nasa example nga illustration. Okay? So, that is for solid carbon dioxide. Now, for carbon monoxide naman, ganun din, isang gas, colorless, odorless, tasteless, nga gas, highly poisonous siya. Take note, highly poisonous gas. What makes it poisonous? Bakit poisonous yung carbon monoxide? CO. Okay? Now, poisonous siya because it has greater affinity. It has 200 times, 210 times greater affinity to hemoglobin. Meaning, ang iyahang ability to attract or to bind to hemoglobin, once ma-absorb siya sa ato ang body, sa blood, once ma-absorb yung carbon monoxide sa blood, naa siya'y high, super high affinity towards hemoglobin. Taas iyahang binding, iyahang capability to bind to hemoglobin. Comparing to oxygen. Kay 210 times gid siya greater affinity compared to oxygen. So say for example, naka-absorb gid ka og high amounts of carbon monoxide. Okay? So imagine niyo na ani siya ang blood vessel. You have, syempre, dili man gyud na makita ang gases, di ba? Pero imagine, hypothetical lang, carbon monoxide na siya ha. Muna siya ang blood vessel, then example lang, hypothetical, naglaklak gyud ka og naglaklak gyud kag inhale og carbon monoxide, nagatubang gyud ka sa tambutso sa sakyanan. Okay, so naka-inhale kag daghan kayo carbon monoxide, And then, andyan na siya, na-absorb na siya sa blood vessel. Then, syempre, may mga oxygen sa blood vessels. That is very important for the tissues, yung oxygen. Kasi yan yung na-inhale ng katawan, di ba? Oxygen. Now, kung andyan na yung carbon monoxide, then we have hemoglobin. Between the two, kung si hemoglobin makakita gina siya carbon monoxide, makasense gina siya carbon monoxide, dili na niya bali-balihon ang oxygen. Okay? Kasi nga again, comparing to oxygen, carbon monoxide has 200 times greater affinity to hemoglobin. Taas iyang binding ability to hemoglobin. Unsa di ay dapat ang purpose ni hemoglobin? 'Di ba si hemoglobin sa ato ang bloodstream, siya yung nagki-carry ng oxygen. Siya yung nagki-carry ng oxygen sa blood. Siya yung bit-bit niya dapat is oxygen. Now, kung merong carbon monoxide na na-sense niya, instead of carrying oxygen, ang i-carry niya ngayon is carbon monoxide. Therefore, pag-deliver niya sa mga tissues, peripheral tissues sa body, dili na oxygen ang mahatag. Therefore, lowered karon ang oxygen level sa tissues causing hypoxia. Okay? Mababa, oxygen. So, mababa yung oxygen sa tissues. Okay? And remember, lahat ng tissues sa katawan, they need oxygen. Okay? They need oxygen for their bodily functioning. Okay? So, kung mababa yung oxygen level sa mga tissues ng katawan, that could lead then to death. Okay? So, systemic poison yung ginagawa ni carbon monoxide. Okay? Systemic poison. Okay? So, delikado siya. Highly poisonous yung carbon monoxide. So, yung major source, again, ng carbon monoxide is automotive exhaust. Okay? Anang sa tambutso ka nang gina-release sa tambutso sa mga sakyanan. Usually, yan yung ang cause ng carbon monoxide. Okay? So, yung treatment, if this really happens, ang treatment is 100% oxygen, of course. Okay? Sa may ang kulang, di ba? Ang kulang is oxygen. Kasi nga, yung nangyayari sa hemoglobin, nakikarry niya na out yung carbon monoxide. So, dapat imong dagdagan ang concentration ng oxygen. Okay? Or, you can have artificial air. Artificial air, ang component ana is 20% oxygen plus, andari na lang. Sorry. Take note. Artificial air, it contains 20% oxygen and 80% helium. Okay, 20% oxygen, 80% helium. Okay? So, tandaan nyo lang na artificial siya nga air, so hindi siya totoo. Artificial man, so dili siya natural nga air. Ang natural air dapat na ini-inhale taas ang amount of oxygen. Now, since artificial, dapat ang inyong realization artificial, so dapat mas taas ang amount sa artificial one nga gas, and that would be helium. So, mas taas ang concentration sa artificial nga gas. Okay? So, gamay ang natural nga gas, which is oxygen. So, artificial air is 20-80 ratio. Okay? Ayaw ninyo ibaliktad ha, kaya usually mabaliktad siya. Basta dumdumi lang, artificial man siya, so gamay ra ang natural nga air gas. Okay? Then, hyperbaric oxygen can also be used as treatment for carbon monoxide poisoning. Okay? Sige, last slide na. Okay? So, carbides naman, another compound of carbon. Pwede siya in a form of calcium carbide. Ito yung kalburo. Familiar man siguro mong kalburo. Kalburo, muna siya ang gina-spray or gina-inject baka ha, depende, ginaunsa na nila pag hatag sa mga fruits para dali ra mo ripen, dali ra mo hinog ang fruits. Okay? To ripen, to hasten, to speed up the ripening of fruits, yung ripening process ng fruits para paspas lang. Okay, so kalburo is being sprayed or injected sa fruits. Yan yung calcium carbide. Calcium carbide. Ang silicon carbide naman, yan naman yung liha. Liha ka ng abrasive. Liha. Okay, ay abrasive. Kanang used to shape, used to finish, used to polish a workpiece through rubbing. Di ba? Ginarub mo na. Rub mo na ang liha. Okay, silicon carbide naman yung active component ng liha. Okay, so silicon carbide. And lastly, cyanides. Cyanide, Cn minus. This is a general cellular poison. Okay, so yung na-mention kanina na hindi kayang i-treat ng activated charcoal, isang cellular poison. Okay, yung mechanism, what is mechanism of toxicity? Paano siya nagkukos ng poisoning sa tao? Ito yung ginagawa niya. Kaya niyang inhibit yung enzyme na cytochrome oxidase of hemoglobin. Okay, so cellular good. Kung yung nga, dili ni kaya sa activated charcoal lang. Okay, kasi yung ginagawa ni cyanide, ini-inhibit niya yung protein na cytochrome oxidase ng hemoglobin. So, pigil ngayon yung respiration. Kasi yung cytochrome oxidase, that is very important for cellular respiration. So, pag inhibited, pigil ngayon yung respiration. Okay. So, overall, these are the important compounds of carbon. After carbon, we have silicon. Silicon, this is the second most abundant element in the Earth's crust. So, the element following oxygen. Oxygen is the most abundant element in the Earth's crust. Its common natural occurrence in nature is in the form of silica. Silica, this is chemically known as silicon dioxide. Silicon dioxide, the SiO2. Okay, so for example, silicon may occur in a mineral quartz or pwede din siya mag-occur in a form of flint sand. Ayan. This is the quartz flint sand. Okay, so the silica or silicon present in this natural mineral is in a form of silicon dioxide. There are also synthetic forms of silica, which are in amorphous form. Example, the silica fume and silica gel. Both differs on the preparation method. They differ on how they are prepared synthetically. So, tandaan, silica fume, this is prepared from condensation of silica, whereas silica gel, this is produced via hydrolysis of silicates. All right, silica gel. And with regards to the solubility property of silicon materials, it is said to be soluble in an acid. Particularly, the acid that can dissolve silicon materials is hydrofluoric acid. Hydrofluoric acid. Now let us proceed to the important compounds of silicon, beginning with the chain silicates. Chain silicates are the asbestos. Asbestos, I have introduced this under the compounds of magnesium. Asbestos is again chemically known as hydrous or hydrated magnesium silicate. So it contains magnesium plus a silicate. Attapulgite or the colloidal activated attapulgite. This has pharmaceutical uses. Okay, this is chemically known as magnesium aluminum silicate, the purified native magnesium aluminum silicate. Again, asbestos magnesium silicate, hydrated hydrous magnesium silicate. Attapulgite magnesium aluminum silicate. This is available or marketed under the brand name Kintes, Diamagma, Polymagma, Diatabs. Para saan? This is indicated for the treatment of mild diarrhea. So very good siya for fast relief of mild diarrhea kasi nga nakastate dito short duration yung action niya. Ibig sabihin, pag short duration, faster yung onset of action niya. Okay, so it offers fast relief in treating mild diarrhea. Bakit pwede siya for the treatment of mild diarrhea? Because it has adsorbent property. Next. After chain silicates, we have the layer silicates, which includes the talc, bentonite. So no problem with this compound, silicate compound, because these are also introduced to you under the compounds of magnesium. So you can just scan over your notes under magnesium for this particular compounds. Talc, bentonite. So take note of the common names nila. Talc is a native hydrous magnesium silicate. Bentonite is a native colloidal hydrate aluminum silicate. Bentonite. Next, the purified siliceous earth, national formulary. So it has a lot of common names. So just take note of the other names of purified siliceous earth. This is actually forms of silica consisting of fragments of diatoms. So para saan? Pharmaceutically, this is used as filter aids. Filter aids, okay? Or pwede din siyang gamitin as mild abrasives. Alright. Next, the silicon dioxide. This is one of the most common compounds of silicon. This is also known as sand, flint, or the silica. Example, the silica gel that is made up of or that consists of silicon dioxide. So para saan ba yung silica gel na usually nakikita nyo sa boxes of shoes, boxes of sandals, boxes of footwears? It is used as an absorbent, di ba? Particularly, isa siyang desiccant. No? Desiccant. Okay? So, para saan ba yung desiccant? It absorbs moisture. Diba? It maintains, sustains the dryness of the particular material. Okay? Bakit siya pwede gamitin as desiccant? Kasi meron siyang absorbent property. It is able to absorb the moisture. And in the pharmaceutical field naman, pwede siya gamitin in preparation of solutions. So, ginagamit siya particularly as clarifying agent ng solutions, filtering agent, or as suspending agent. Okay. Now, for the toxicity of silicon dioxide, there are actually occurrence of toxicity ng silicon dioxide, and this is known as silicosis. Silicosis, this is a respiratory disease, so affected yung, particularly yung upper respiratory system. So yung usual clinical manifestation of having silicosis, poisoning of silica dust or silica fumes, ang usual na clinical manifestation is similar to tuberculosis. Ano ba yung usual symptoms pag may TB? Diba? Hemoptysis. Hemoptysis. Ano ba ibig sabihin ng hemoptysis? Hemoptysis, ito yung presence of blood in septum, yung nagluluwa ng dugo. Okay, presence of blood in septum. So almost the same similar symptoms, clinical manifestation with TB. Yan yung silicosis. Antidote is aluminum oxide, the Al2O3. Bakit siya pwede gamitin as antidote for silicosis? Because it forms coat on silica particles. Silicones naman, example, the dimethicone, simethicone. Present siya sa mga anti-acid formulations. So example, sa dimethicone, present siya sa simico na antacid. Ano yung gamit ng mga silicones in antacids? Anti-flatulent, anti-gas. Okay, simethicone, present naman siya sa Kreml S plane, sa Maalox plus. Alright, so anti-flatulent, yung mga silicones in the preparation of antacids. And we also have potassium aluminum silicate. This is just a mineral, the most common rock feldspar. Alright. Next, let us proceed to silanes. Okay, silanes, this is actually a compound of silicon which has analogous property to alkanes. Alkanes is actually an organic. This is an organic compound, is saturated hydrocarbon. So kung titingnan mo yung structural formula niya, it forms four single bonds with hydrogen. That is why yung formula niya is CiH4. It forms four single bonds to hydrogens. Alright, so this is a saturated hydrosilicons. Okay. Glass, finally, glass po yung isa sa mga pinanggagamitan ng mga silica materials. Okay, most of the glasses, they contain silica, silicate material. Take note, glasses, they contain silicate materials, and they are usually prepared by fusing a base. Example of bases, sodium carbonate and calcium carbonate. It is being fused with a pure silica. Now, if you'll try to observe glasses at your homes or in any places, when you observed a glass or a glass-based material, yung appearance nila, yung characteristics ng mga glasses, iba-iba. That is because ang mga glasses, they can be modified by different addition of elements. Okay, so may mga elements being added, being incorporated to glasses para ma-modify yung appearances nila, modify yung mga characteristics ng mga glasses. So, say for example, manganese dioxide. Yung manganese dioxide, it is being added to a glass material to mask the blue-green color of iron, which is usually present in silica. Another example is boron, yung borate. Borate, if it is added to a glass material, that can decrease the coefficient of expansion. Normally, when a glass is being heated under a set condition or under a set temperature, glasses usually expands. But with the addition of boron or borate materials, they decreases the coefficient of expansion of glasses. So examples are the vials. Okay, yung mga vials container, they are usually added with boron or borate to decrease the coefficient of expansion of their container. Another example of an element that is being added to glasses to modify their characteristic is potassium. Potassium naman, it renders light resistance property to a glass. In fact, this is the element that makes the glass amber colored. So I know you're all familiar with this type of glass, yung kulay brown color na glass. That is because of the addition of potassium that renders the glass light resistant. Okay, kasi may mga gamot, may mga solutions, liquid solutions that are said to be photosensitive. Ibig sabihin, hindi sila pwede exposed sa light. Alright? That is why we have this kind of container para light resistant. Okay, yung bottle. Okay, that is to maintain the stability of the uh, contained solution in that particular vessel. And lastly, lead. Lead is also another element that can modify the characteristic of glasses. So this particular element increases the refractive index naman of a glass. All right. These are just good to know na mga chemistry of colored glasses. So, kung curious mo, bakit iba-iba yung kulay ng mga glasses? It is also because of the different elements being added to it. So, you can just read about this. Pag kulay green, it is because of iron. Pag kulay blue, it is because of the copper, and so forth, and so on. So, these are just good to know. The chemistry of colored glasses. Again, color characteristics of glasses, that is also because of the addition of elements or metals added to the glass. Okay, after silicon, we have tin. Tin with the elemental symbol Sn. This comes from the Latin word stannum. Okay, so yung common na industrial use ng tin, this is used in the manufacture of tin cans, diba? Yung mga tin cans, obvious naman, tin cans, it contains the metal of tin. Another example, yung mga sinaunang utensils, and I think this is still available, may mga tin based tayo na mga utensils. Alright? Then for the natural occurrence of tin as a mineral, it can occur in a form of cassiterite or chemically known as tannous or tin dioxide. All right. Then for the alloys of tin, okay, we have different alloys of tin. Okay, take note again, what is the purpose of having alloys? Combining one or two or more. Okay, two or more metals. That is to provide greater strength. Okay, for that method para mas resistant sila sa corrosion. Alright? So solder metal, pewter metal, gunmetal, and gunmetal and rose metal. So these are the alloys containing tin. So just take note of the concentration of the tin present and what are the other elements present in each alloys. Okay, for the compounds of tin, we will just discuss two important compounds of tin, starting with stannous fluoride. Stannous fluoride, this is present in a dentifrice. Okay, this is an anticardiogenic, particularly at 8% concentration. This is present in the formulation of the brand Crest. Okay, this is a toothpaste, a fluoride containing dentifrice that is approved by American Dental Association. Crest. Take note, has stannous fluoride present siya sa formulation na Crest. Then stannic oxide, this is a protein precipitant. Okay, that is why pwede siya as germicide against a specific species of bacteria, the staphylococcal infections. Next, lead. Lead comes from the Latin word plumbum. Okay, so among the elements under group 4A, this is the most metallic element. Alright, this is based on the periodic trend. If you recall, going down a group, increase yung metallic property. And since lead is found at the bottom part of the one of the elements in the bottom part of group 4A, this is said to be metallic in nature. Okay, so this is usually added to phosphorus to render phosphorus black in color. Then when it comes to qualitative test, okay, in the laboratory, If we have a sample solution containing lead, example Clambus, the lead 2 plus, it usually forms black precipitate with a sulfur containing reagent. So ito yung sinasabi kong exception. If naaalala nyo, so yung lead, part siya ng group 1 cation. Part siya ng group 1 cation which forms insoluble chloride precipitates. Pero at the same time, lead may also form black precipitate in the presence of sulfur containing reagent. Alright. Then for the pharmacologic actions of lead, there are compounds of lead that are used as astringent and also protein precipitant. Okay. Natural occurrence of lead in a form of galena. So that is the galena, the lead sulfide. Now with the toxicity, very poisonous yung lead. Okay? Very toxic yung lead element. It causes cumulative poisoning. Ibig sabihin ng cumulative poisoning pag na if the lead is being absorbed in the body, it accumulates. It is deposited in a particular um, site or organ in the body. So cumulative, it accumulates, okay, in a particular organ of the body. Particularly, being affected talaga during lead poisoning is the nervous system. Okay? And example sa mga effects ng lead poisoning is the lead encephalopathy, and the lead palsy. Okay? So, pag lead encephalopathy, so again affected yung nervous system. So, it has something to do with the brain. Okay? So, nagiging irritable, memory loss, projectile, vomiting. These are the common clinical manifestation of having lead encephalopathy. Irritable, memory loss, projectile, vomiting. Lead palsy naman, this is a having degenerative changes in motor neurons. So yung usual nga manifestation having lead palsy is yung wrist drop or the foot drop. Okay, and the antidote, remember, lead is a heavy metal. Lead is a heavy metal, so pwede gamitin yung EDTA. Okay, or aside from EDTA, pwede gamitin yung editate calcium disodium under the brand name calcium versinate. Alright? Again, aside from EDTA, pwede gamitin yung editate calcium disodium under the brand name calcium versinate. Ano ba yung mga sources having lead poisoning? Ano yung sources ng poisoning caused by lead? It could be lead pipes, through lead pipes. That is why ngayon, yung mga water pipes hindi na made up of lead. Kasi madali lang mag-corrode yung lead metal. Okay? Then paints. Okay? Paints can also be sources. There are paints before that contains lead. Crayons. There were crayons before that contains lead. Batteries and automobile exhausts sa car. Pero ngayon, most of the automobile gasoline is already unleaded. Diba? Most of them, ang mga available na gasoline are unleaded. Okay. Then for the important compounds of lead, una, we have the lead acetate. This is also known as the sugar of lead. Sugar of lead, this is used as astringent, antiseptic. Okay, this is very important in the preparation of lead subacetate solution. Lead subacetate solution, this is the Gollard's extract. Okay, so the reason bakit yung Gollard's extract has astringent antiseptic property, it is because of the lead acetate on it. Then we also have the basic lead acetate. Okay, yung lead monoxide naman, example, yung litharge. Yung litharge in particular, ito yung ginagamit in cementing pipes. Okay? Water pipes. And we also have the plumbers, solders. Yung ginagamit pang sulda. pang-connect together ng mga water pipes or tubo. Okay? So, bakit pwede gamitan yung plumbers? Siya ang the best one na metal or alloy of tin. Okay? In soldering. It is because of its low melting point. Madali lang siyang mag-melt. So, yan, siya yung usually ginagamit for soldering joints. And finally, we have germanium. Germanium, this was discovered by Winkler, who coined the term ecosilicon. This was coined by Mendeleev. Okay. Germanium is usually present in few dietary supplements. Very good siya for immune system enhancing. And meron din tayong mga germanium na usually prescribed by the doctors as anti-tumor. Okay. Another is the compound germanium dioxide. This is good for the treatment of anemia because it has been found to increase the formation of red blood cells. That is why pwede siya for anemia. For the group 4B elements, or also known as the titanium family, all of the members under this group possesses amphoteric properties, pwedeng acid, or they may also act as bases in some at a particular set of or nature of solution. All right. So members under this group, we have the titanium, zirconium, hafnium, rutherfordium. These are rare. Okay, rare po siya nga mga elements. Pero among this, ito yung pinaka may use pharmaceutically, yung titanium. Okay, so let's start with titanium. This is also known as titans or the sons of the earth, the ninth most abundant element on earth. For its uses, this is a reducing agent, a powerful, strong reducing agent. Another thing, we have compounds of titanium that is being used in the preparation of sunscreen. Bakit pwede siya sunblock and sunscreen? It is because it reflects UV rays from the sun. Example, yung titanium dioxide. Yung titanium dioxide, present siya in some creams. Okay, sunblock preparation. Again, because of its solar ray protective property. Also, it causes white pigments in creams. Okay, kulay puti yung creams. Kasi yung titanium dioxide, kulay white. Also, yung mga white capsules. Okay, bakit may mga white capsules, may mga parte ng capsules na kulay white? It is because of this opacifying agent, the titanium dioxide. Alright? So, bakit it contributes opacity? Okay, in the preparation of white capsules because of its property na high refractive index. Okay, it has high refractive index which contributes to its opacity. So this is an example of a commercially marketed sunscreen which contains titanium dioxide at 4.9%. Okay, it has titanium dioxide. For zirconium, we have official compounds before that were used pharmaceutically as antiperspirant and for athletes' food. But ngayon, it has been banned, it has been withdrawn from the market, particularly yung mga antiperspirant treatment for mga creams for athletes' food containing zirconium oxide, zirconium carbonate. They were already withdrawn in the market. They have been banned. Okay, it is because of the effect nila na nagko-cause sila ng granuloma formations or skin cancer. That is a type of skin cancer, granuloma. Okay, so same with aluminum. Yung mga aluminum containing na antiperspirant, okay, they were already banned from the market. And again, that is because most of them cause skin cancer. And finally, hafnium. Hafnium, this is just a rare element, no pharmaceutical use. All right, it occurs in small quantities in zirconium ores.